The auto teach function is an easy to use vision tool where you simply train it on what a good part is. There's no need for any complex programming or multiple tools to solve the application. So as you can see in this example, this is using conventional tools to solve an inspection of a connector here. So if you wanted to look for stains in this metal area, stains in the plastic area, bent pins, missing pins, things like that, you would need multiple vision tools to solve this. So in the next section we'll show you how the auto teach tool can do all this in one easy to use tool. To add the auto teach tool to the inspection, simply click add tools, and it falls under two categories. It falls under the presence discrimination category and also the stain flaw category. The only difference between the two is under the presence discrimination category, the auto teach will report back the percentage of good pixels for the judgment, and you put a limit on that. In the stain flaw category, it will report back a volume of bad pixels. In other words, how much bad pixels and how far away they are from the good parts. So the presence absence category is good for just general presence absence, simple pass fail, is it there or is it not there? The stain flaw category is better for either presence absence and looking for scratches, dings, dents, and other flaws. So again, the only difference is how it judges the flaw. The algorithm's the same. So you simply pick the category and add the auto teach tool. It has a nice guided menu system that you can read over if you want. It shows you the steps, and then you simply start programming the tool. The first step with setting up the auto teach inspection tool is to set up the part location. This is an automatic function built into the tool where it will locate and find a unique pattern on the screen and move the tool accordingly. So if your part moves around on the screen, the tool will move with it. So simply trigger on a good part at first. So you can see we have the Y connector here, and just move the green box to locate a unique feature about the part. So in our case, we're just going to put it around the whole body of the part. If you need to rotate the rectangle, you can actually rotate it as well by grabbing that red handle. But once you have the box where you want it, the green box, you can click register. And it will store that feature here, as you can see, the pattern. And that's what the pattern that will locate. The blue box, by the way, this blue is the search region, so it'll, as a default, it'll look for this pattern anywhere on the screen. 30 degrees of angle is already built in as a default. If you need more rotation, you can raise that number, or if you have no, little less rotation, you can lower it to save some time. But the default's 30, so we're just going to go with that. And when you're ready, just simply click to the next step. The second step in setting up the auto teach inspection tool is to add your inspection region. You can choose from rotated rectangle, rectangle, circle, oval, ring, or arc as the different regions. The default is rotated rectangle. So to add a region, just simply click Add Inspection Region. It'll bring it in here in the box in blue and simply draw it around the area of interest that you're looking for to inspect for flaws. So in my case, again, I'm going to draw it around the whole body of the part because we want to look for flaws everywhere inside this Y connector, the body of the part. We want to see if it's bent or missing. So basically, you want to draw it around the whole part. It's the area of interest. You can add up to 32 inspection regions if you want by just simply clicking Add again, or you can also add mask regions as well. And as soon as you're ready, you can click Next to go on to the next step. The third step in the auto teach tool process is the learning process. So this is where we're going to literally auto teach it on what a good part should be. So to do this step, you're going to need at least a minimum of 30 good parts. So get yourself a batch of known good parts ready to trigger through. The more the better, so if you have more than 30, that's even better because it will give it a better statistical analysis of what a good should be. And when you're ready, go ahead and click the record button here to start the recording process and start running the good parts here. So I'm going to go ahead and trigger and start running my good parts, and you can see the image here is automatically corrected based off of position correction here, and literally run your good parts. So when you're ready, I'll go ahead and stop the triggering. So once you have your good patch run, just go ahead and stop the recording by clicking the record button again and click the teach quality image. So what it'll do is it'll literally analyze all that image data that we just taught it, and based off the statistics of the good parts, each pixel is going to essentially have a tolerance on what a good part should be. And when you're running this inspection, if any of those pixels fall outside that good range, it'll be detected as bad. You'll also notice as a default here, you might have some of the data might have a red X on it, as you can see here. If I click on that image, you can see this was recognized as a defective automatically. So if you mix in any bad parts on accident, like in this case, a bent pin, it automatically detected that this fell way outside our good range, so it automatically flagged it as a bad part and did not include it in the auto teach data. So kind of a nice feature built in. If you accidentally mix in a bad part, it will detect that. So as soon as you're ready, you can go ahead and click to the next step and verify the tool operation. After you have performed the 3 main steps of the auto teach tool, you can now verify the judgment result. So all these settings have been set for us automatically when we did the auto teach process. So the upper limit for the stain volume and stain size and everything's already been set for us. And what you can do is just simply verify the good parts. So I'll go ahead and trigger through some good parts. Those should pass. And what you can do is run some bad parts just to verify if it actually is picking up the no good parts correctly, as you can see here. And we got a nice little contrast view here. So what you can see is it's kind of like a map of where the flaws are occurring. And it's a color-coded system here. So the pixels that are not too far away are kind of blue and greenish. And the pixels that are further away from the good data turn kind of yellow and orange and red, so kind of like a weather map almost. So you can kind of tell where the bad flaws are occurring, bad pixels if you will. So you can see a flaw down here in the white area, and you can always verify the measured volume as well. So again, it's kind of like a sum of all the bad pixels here adding up. So the higher the volume is, the further away they are from the good data. So you can scroll through some parts, you can see we're picking up flaws or stains in that metal area. So again, one tool is picking up flaws anywhere in this metal area, bent pins, flaws in this white area, or any kind of unknown flaws, anything that falls outside our good range. While you're still on this stage, also you can add good data if you want. So if you had some good parts that were actually failing, you could verify the volume, and then if they do need to be added to the data, you can always add them there. And you can also switch, by the way, between the contrast and raw image if you want. So you can see in this case it's the wrong colored connector, so that's why this one's failing. So you can always switch between raw and contrast image. So when you're done, just simply click the Done button here, and then you can go ahead and go to run mode and run the inspection. So if you haven't saved your changes yet, it'll ask you to save them. So we'll go ahead and click yes, and simply run the tool. So the tool is ready to go. Nothing to do, nothing else needed here. And while it's running, you can verify the raw image, as you can see here, but you can also view the contrast image while it's running as well. The measured volume is displayed live as well, so it's real easy to verify and confirm the operation of the tool.